We're going to look at trigonometric identities. An example of a trig identity would be something like this. Say sine theta times a quantity cotangent of theta plus tangent of theta equals secant of theta. So in other words, what we're looking at today is proving or establishing an identity. When you go through this, you make one side look like the other. Okay, that is, you take the quote harder side, in this case left side, and make it look like the right side. Or you might make the right side look like the left side. You don't work with both sides at the same time and make them look like each other at some point. You take one side and make it look like the other side. We'll go through this in a minute, but before we go through and actually work out some identities, I just want to show a few tricks you might use in proving an identity. One thing is, say you have something like this. Now this is not an identity. For it to be an identity, there has to be an equal sign in it. But as far as going through something like this, a trick you might use in simplifying is writing everything in terms of sine and cosine. Okay, that's kind of one you use a lot, writing everything in terms of sine and cosine. Cotangent of theta, we know, is cosine of theta over sine theta, as far as one of our quotient identities. Secant of theta is 1 over cosine of theta, as far as a reciprocal identity. You can see the cosines divide out, and so I get 1 over sine theta, which we know is cosecant of theta. All right, so one thing is writing everything in terms of sine and cosine. Sometimes you'll go through multiplying by a form of 1. A form of 1 would be where the numerator and denominator are the same thing. So on this one, I'm going to multiply numerator and denominator by 1 minus cosine of theta. Okay, multiply numerator and denominator by the same thing as a format of 1. So in the numerator, I'll just leave it side by side. But in the denominator, I can multiply that out. That is, I know a plus b times a minus b is a squared minus b squared. The difference of squares. So I get 1 minus cosine squared. But what is 1 minus cosine squared? Well, it's sine squared by a Pythagorean identity. Okay, that's sine squared plus cosine squared is 1. Now, notice I can use some algebra. Put this in the lowest terms. I got a sine over sine squared. So that becomes 1 over sine for that part of it. That is like x over x squared is 1 over x. So what I have here now is 1 minus cosine over sine. Then what I can do is split up the numerator or the denominator. That is, I can think of this as 1 over sine minus cosine over sine. But what are those? Those are cosecant minus cotangent, and then we're done. A lot of times you may find a common denominator. For example, if I have 1 over 1 minus cosine of theta, 1 over 1 plus cosine of theta, the common denominator is 1 minus cosine times 1 plus cosine. And so as a result, what I can do is the common denominator ends up being the product of these. There's nothing in common to them. That is, if I had like 1 minus x and 1 plus x, the common denominator is 1 minus x times 1 plus x, same thing going on here. So I got to multiply numerator and denominator of this one by 1 minus cosine, and numerator and denominator of this one by 1 plus cosine. All right, so what do I get? Well, I get 1 plus cosine. Sometimes 1 is just itself. Here I get 1 minus cosine. Here I get 1 plus cosine times 1 minus cosine. All right, but what is that? Well, that's 1 minus cosine squared. Okay, 1 cosine minus cosine squared as far as foiling it out. Notice cosines drop out here. I get 2 over 1 minus cosine squared, but 1 minus cosine squared is sine squared. And so then I get 2 cosecant squared of theta. And another one trick you might use is going through some factoring. For example, if I have cosine squared of theta minus 1 over cosine squared of theta minus cosine theta, the cosine squared of theta minus 1 is cosine theta plus 1 times cosine theta minus 1. What I have in the denominator here, I can factor out a cosine, and I'm left with cosine theta minus 1. Okay. Like if I had x squared minus x, for example, I can take out an x, so I had x times quantity x minus 1. That's what's going on here. I take out a cosine, so I got cosine theta minus 1. All right, now I can see these cosine theta minus 1s divide out. Then I take this and split it up over the denominator. As I got cosine over cosine plus 1 over cosine. And so I get 1 plus secant of theta. All right, so those are just some different tricks. Going through different algebra tricks, common denominator, factoring, you'll be doing some. And then a lot of times when you have some expression, writing everything in terms of sine and cosine. All right, now let's actually think about some of these tricks and go through and actually establish a person identity. So I'm showing the first one I had. Now, clearly the left side's a more complicated side, and so we'll work with that one. I want to make that side become secant theta. Now, when you got everything that looks like kind of a mess here, what can I do? I can write everything in terms of sine and cosine. So what I have here, that is, I could go ahead and say this, or if you want, you could just say LS, like left side, equals sine theta. Now, cotangent is cosine over sine, and tangent is sine over cosine. Now, look at what I got in the parentheses there. I'm combining two rational expressions, so I got to find a common denominator. The common denominator is sine times cosine. Now, I'm not saying that's what always happens, but a lot of times when you go through these problems, the common denominator will be the product of the two denominators that you have. Not always, but that's what's going on here, certainly. And so I got to multiply that first denominator by cosine. I'll just put C over C here. And multiply the second one, numerator and denominator, by sine. And so I get cosine squared plus sine squared over sine times cosine. Sines divide out. Sine squared plus cosine squared is 1. And 1 over cosine, you get secant of theta, which is the right side, and we're done. All right, take a look at this one. Cosecant of theta minus 1 over cotangent equals cotangent of theta over cosecant theta plus 1. Now this one side of the identity is about as hard as the other, so it really wouldn't matter which side you worked with. I went ahead and worked with the left side, but you can just as easily work with the right side. All right, now notice that you got a minus 1 and plus 1 here, so you might think, well, I want this to somehow look like this. I want to get this cosecant of theta plus 1 somehow in that. And so what I could do is just multiply numerator denominator by cosecant of theta plus 1. This would be a format of multiplying by 1. Okay, I want to get that down there, so that gives me some ideas. Multiplying the numerators together, I get cosecant squared theta minus 1 because it's a difference of squares. The denominator, I get cotangent of theta. I'm just writing this side by side. Not really anything going on there. Now, cosecant squared minus 1, that ends up being cotangent squared. Leave the denominator as is. Okay, so basically, I'm assuming you know your different trig identities as far as some of the basic ones. You've got your reciprocal identities as cosecant of theta is 1 over sine, secant of theta is 1 over cosine, cotangent is 1 over tangent. You got your Pythagorean identity, sine squared plus cosine squared equals 1. You got your cotangent squared plus 1 is cosecant squared, etc. Then you got your quotient identity, so that tangent is sine over cosine, cotangent is cosine over sine. But anyway, going back to this problem, cotangent squared over cotangent is cotangent, just like x squared over x is x. And so, ta-da. Take a look at one more. Let's take a look at the following. I'm getting there. So I have 1 minus sine theta divided by 1 plus sine theta equals secant theta minus tangent theta quantity squared. All right, I worked with this side. Now, by the way, I'll mention that with identities, there is not necessarily just one way of doing it, okay? I'm looking at this side and I'm going to make it look like this side. You might work with this side, make it look like this side. So, I mean, there's more than one way, okay? Anyway, so I'm taking the right side, and I need to multiply this out. You might remember the format for a square of a binomial, or I'm just writing it out and foiling it. So doing that, I get secant squared of theta minus 2 secant theta tangent theta plus tangent squared theta. Now, look at what I have over here. I got a sine. I don't have secant and tangent. When you get something complicated, what do you want to do? Write everything in terms of sine and cosine. Okay, so secant squared is 1 over cosine squared. Then I got 1 over cosine. What's tangent? Sine over cosine. So tangent squared is sine squared over cosine squared. All right, so I get 1 minus 2 sine theta plus sine squared all over cosine squared. All right, so this is maybe easier what it could have been. I've already got the same denominator, so I don't have to worry about that anyway. Okay. Now, what I can do with this, notice that I got a cosine squared here. There's no cosines here. So it might seem reasonable, maybe I want to rewrite what cosine squared is. I know since sine squared plus cosine squared is 1, cosine squared is 1 minus sine squared. Now, what I'm going to do is factor. 1 minus sine squared, it's in the format of difference of squares. That is, I know that a squared minus b squared is a minus b times a plus b. 1 minus sine squared we know is 1 minus sine theta times 1 plus sine theta. Now what I have here, this is sine squared, but this is a minus 2 sine theta. This is going to be 1 minus sine theta times itself. And you can see where you're heading towards. It's that. So it might seem reasonable that what you have in the numerator would be that anyway, because you can see this divides out. So if you kind of look at where you're going, then that might kind of help you think about how to factor something. Okay. Anyway, let me scoot it up here. You can see that. I factored, divide these out, and so I'm left with that.